Okay, so hello and welcome once again to Conceptual CEE, where concepts are made easier and easier, right? Right. So as we were talking about malaria and the life cycle of Plasmodium, we had already completed the introduction portion where we had known something about malaria, something about Plasmodium, and the comparison table between different species about their fever, quartan fever, benign tertian fever, cerebral malaria, black water fever, and etc. Including the incubation periods too. Right, right. So we will be continuing to our first part. If you haven't watched that, then please watch these videos in order so that it makes a complete sense. Right, right. So we will be continuing with that, and today we will talk about the life cycle of malaria, life cycle of Plasmodium in the human host. Yes, human host was secondary host where asexual life cycle occurs. First life cycle, asexual life cycle, asexual part of life cycle. Okay. So now, talking about the life cycle in human host, we will be seeing it in a detailed animation today. And trust me, I have made this video just because such type of videos are not available on YouTube. So please make it available to all those who need it. Make it available to all. Share it to your friends who need it. Okay. Okay. So let's start our video. And in doing this video, I will use some terms in Nepali. Please don't get confused in that. That will not be the technical term actually. Okay. Okay. So myself, Asik Jha, I am a second year MBBS student at Maharajaganj Medical Campus, IOM. Okay. Now, let's see the animation portion. So, there is a mosquito. That mosquito bites us, right? And it introduces sporozoites. These are the sporozoites. What I had said, sporozoites are the main causative agent, right? No, infective agent, infectious form. They come to the liver and now they infect our liver cells. Okay, there they become schizoid, then merozoite. We will be seeing this in detail in the upcoming slides. Now they are liberated. They come to the blood again. They infect the blood as merozoites. In the blood, they undergo erythrocytic schizogony. In the blood, they undergo erythrocytic schizogony, and again they replicate and rupture the blood, and they invade the new blood cell, new RBCs, as well as some of them will form gametocytes, right? Some of them will form gametocytes, and these gametocytes will be sucked up by the new blood meal of the mosquito. Okay, and in this way, the life cycle will alternate itself, and again the mosquito will bite us, and we will get sporozoites, right? So let's see this animation in the form of slides, and let's learn many things out of this lecture today. Let's make it out. So life cycle of Plasmodium as per NCBI, we had discussed it in the previous lecture also. This is human host. Human host has two cycles. That one is in the liver, one is in the liver. Okay. So in the liver we have pre-erythrocytic and exoerythrocytic cycles. We will see it later. Then in the RBC, erythrocytic, and then in the mosquito. We will be seeing the life cycle of Plasmodium in mosquito in our next lecture. Okay. Okay. So now in the next subsequent slide, we will be seeing this stage in the liver. Okay. Okay. So let's start our liver cycle. So what happened? You guys, you are living in an area which has stagnant water. Stagnant water means very good condition for mosquito to lay their eggs, and very good condition for their hatching out, right? So mosquito in your area, that mosquito comes and bites you here, right? Biting of that mosquito, what does it do? It releases a sporozoite. That sporozoite comes to your liver. Okay, that sporozoite comes to your liver. So now let's see what happens in the liver then. So this is imaginary, this is considered as the liver, and we will see what cycle happens here. Okay, so sporozoite, that was infective form, right? Sporozoite, infective. This sporozoite enters into the pre-erythrocytic cycle. Pre, why? Because this is before erythrocytic and it happens in the liver. Don't forget this thing. Okay, so now these are the sporozoite. Let it be even one sporozoite. We will be talking about one sporozoite only from now onwards. Okay, so one sporozoite that enters into the hepatocytes, they are hexagonal, right? Nucleus. Now what happens? It enters as a sporozoite, but now it starts to increase in size, right? And becomes somewhat round in shape. And this is schizont. What is this? Schizont. We call it schizont. Okay. Okay. It fed up upon the nutrients in the hepatocyte and it increased in size, right? And becomes round. And now it is called schizont. The schizont now divides by multiple binary fissions. The schizont now divides by multiple fissions to give lots and lots of cryptozoites, right? Cryptozoite. Okay. Now those cryptozoites, they are released out of the liver cell and they are released as cryptomerozoite. Okay. Now this whole cycle repeats in the exoerythrocytic cycle. This whole cycle repeats as exoerythrocytic cycle, in which these cryptomerozoites again invade a fresh liver cell. And the cycle continues like in the exoerythrocytic cycle. It continues like this. Again, these cryptomerozoites invaded a fresh liver cell, converted into schizont, cryptozoite. Okay, this is metacryptozoite, right? Metacryptozoite, and this is metacryptomerozoite. Okay, in the metacryptomerozoite, what you will see is this metacryptomerozoite, the last final product as cryptomerozoite was in the pre-erythrocytic cycle. Same thing in case of exoerythrocytic cycle is called as metacryptomerozoite. Okay, nothing is changed. Simply, pre-erythrocytic cycle starts from sporozoite. Exoerythrocytic cycle starts from cryptomerozoite. Right. Schizont same. Then in place of cryptozoite, we call it metacryptozoite. Okay, and in case of cryptomerozoite, metacryptomerozoite. Okay. Now, what happens after the exoerythrocytic cycle? We see two types of metacryptomerozoites. See here, one is larger, one is smaller. The larger one is called mega or macro metacryptomerozoite. The larger one is called macro metacryptomerozoite. A smaller one is called micro metacryptomerozoite. Okay, macro and micro. What happens is micro has the tendency to go to blood as well as but macro does not have that tendency. It's simple. Fatty people do not like to run, right? So the fatty macro metacryptomerozoite, it didn't like to run away from hepatic cells. Thus, it stayed there and it continued the life cycle it continued the liver schizogony. Okay. Now comes the point about relapse and hypnozoites, right? So see here, what happens is some of the metacryptomerozoites, they stay as hypnozoite. Hypnozoite is a resting stage. What is this? Resting stage. This is called as hypnozoite. These hypnozoites remain in the liver of the host body. Okay. Now what happens is after a certain period of time, in this time, suppose you got malaria, right? You took the medicines, you took the treatment, okay, and you are all well now. You are all set to go. Okay. Now what will you do is, you won't care for the resting stages that might be present in the liver because that won't show any symptom. After some years, after 1 year or after 2 years, what you will see is you again will have some relapsed fever, and this was not due to new mosquito bite, but this was due to the previous one. What happened was at that time some of hypnozoites were remaining in your liver, and those hypnozoites now became active and they caused the relapse of malaria. So relapse of malaria is due to hypnozoite. Relapse of malaria is due to hypnozoite, and relapse of malaria is not seen in Plasmodium falciparum, Plasmodium malariae. Relapse of malaria is not seen in Plasmodium falciparum and Plasmodium malariae. Okay, because these species of Plasmodium do not have exoerythrocytic cycle. Okay, these do not have exoerythrocytic cycle, so hypnozoites are absent. We will see later about something called recrudescence. What is that, and how is it similar to relapse? Okay, that occurs in case of Plasmodium falciparum and Plasmodium malariae. We'll see that later. Don't worry. So for now, Hypnozoite is resting form responsible for relapse. Okay, pre-erythrocytic cycle starts from Sporozoite, ends with Cryptomerozoite and exoerythrocytic cycle. Now let's see what happens when this micrometacryptozoite enters into the RBC. What does it manifest into? Right. So let's see the erythrocytic cycle in case of human beings. So what happens is, now these micrometacryptozoites, they are released into the circulation, and in the circulation they complete their erythrocytic cycle as this. This erythrocytic cycle is the culprit for your fever because it releases hemozoin. That hemozoin is responsible for chills and fever. Okay, chills and fever. This is typical to malaria, typical presentation of malaria. Okay. So we will see this. Don't worry, we will see this in the next slide in the broken up form. Okay. So what happens is, consider this is a blood vessel, or this is the vascular supply, vascular organ of the body. Okay, vascular supply, vasculature. Now what happens is the RBC, fresh RBC, is invaded by our micrometacryptomerozoite, or simply merozoite for now. Okay, because we will see at the completion of this cycle, merozoites will be released, and new merozoites, they will also come into the same cycle. Okay, so merozoite that invades a fresh RBC, right. Now after invading the fresh RBC, how does it do? Yes, it converts into the feeding stage or trophozoite. Now this is trophozoite. Okay, what happens here is it consumes lots and lots of food. When you consume lots and lots of food, what will you do? This is now trophozoite. It consumes lots and lots of food. Trophozoite means feeding form, right? So consumes lots and lots of food, and what will it do then? It will increase in size, right? The size will increase so much for digestion that nucleus will be pushed to periphery. Trophozoite feeding stage feeds a lot in the hemoglobin. Okay, and now it has to digest that, so it increases the vacuole. This is the vacuole. Okay, in signatoring stage, what you see mostly is your vacuole, that is non-contractile, and it appears in the center, as well as the nucleus is pushed in the periphery. It gives the appearance like a ring. In a ring, you have seen this is something like a ring. Okay, this is a ring, and here is a gem or something. So this is like a ring. This gem resembles nucleus, and this ring structure is vacuole. Okay. So this is called signet ring. Now, after some time, what happens? Consider as we do. What we do? We eat and then we sleep. We sleep. Okay, we sleep unconsciously, and our hands and legs are placed randomly, haphazardly. Okay, so same thing happens here too. After signet ring, there is amoeboid stage. Amoeboid stage has irregular outline. That is why it is called amoeboid, because amoeba has no part definite shape and size. Right. So amoeboid stage, irregular outline. Now what happens is, in this amoeboid stage, there is the formation of hemozoin, right? Hemozoin. So what happens is, there is something called hemoglobin, right? Hemoglobin. This hemoglobin has got heme and globin. The parasite Plasmodium is able to digest this globin, and it digests this. But the heme structure, it gets converted into hemozoin. And what does this hemozoin do then? This is undigestible part, and that is why this hemozoin is toxic. What sort of substance is this? This is toxic. Okay. So let's see. Now this toxic substance hemozoin starts to accumulate in the amoeboid stage, not amoeba. Okay. Now this toxic substance accumulates, and these are those hemozoin. Okay. In the size, now this stage, next stage is called as Saison stage, in which the RBC becomes paler and larger. It shows a number of granules. These are the granules. See, these are the granules. These granules, in case of Plasmodium vivax, is called as Scoffner's dot. In case of Plasmodium falciparum, Mauler's dot. In case of Plasmodium malariae, Zyman's dot. In case of Plasmodium ovale, James dot. Okay, so here we will consider this as Scoffner's dot. Yes, UFFNERS, Scoffner's dots. Okay. Okay, so we will consider it as Schaffner chart in case of Plasmodium vivax. Okay, okay, we have discussed about other Plasmodium species, and it is called what in those cases. Okay, so hemozoin is formed in amoeboid stages. This is a probable question that might be asked in your CE. Do not forget this. Hemozoin is formed in amoeboid stage. Now after this Sison stage we have discussed, then comes Rosette stage. In the Rosette stage, that the single nucleus divides into many, and the cytoplasm also goes to them. So this is something like rosette. This is something like your rosette. Okay, so this is your rosette. These are your rosettes where there are nucleus. The nucleus, although in the figure there are not so many nucleus, but the nuclei are up to 12 to 24. Okay, 12 to 24 nuclei. Okay, okay, and each of these nuclei, they will be forming a new merozoite. Each of these nuclei, they will be forming a new merozoite. So this is the merozoite stage where different merozoites are formed from those rosette nuclei. Right, right. Along with these merozoites, you can see at the center there is something dot granular. This is nothing but this is our dear, this is our lovingly, this is our hemozoin. Okay, okay. So now what happens is, now this RBC is swollen, right? Now this RBC is increased in size. When it passes through, the spleen is also known as, yes, graveyard of RBC. There it ruptures. So what happens is, now this blood vessel, this will lead to spleen, right? These blood vessels will lead to spleen, and in the spleen, when that merozoite comes, it has to rupture because it is so larger, it is drawn out. Now the spleen thinks to rupture it, to kill it, right? So in the spleen, the merozoites rupture. With the rupture of merozoites, with the rupture of RBC, there is the release of merozoites, as well as there is the release of some these are hemozoin. So the hemozoin is released in spleen. The hemozoin is released in spleen. A storehouse of hemozoin is spleen. A storehouse of hemozoin is spleen. You will not forget this. Trust me. All of these, we are dealing with these conceptually, and all of these are probable MCQs. All of these can be asked to you. So what happens is, when this hemozoin is released, this release of hemozoin, this corresponds to fever, and fever normally occurs during afternoon, about 12 or 1 p.m. Okay, and this continues for 8 to 10 hours. This fever continues for 8 to 10 hours. Oh, sir, so large time. Yes, so much large time. And that is why some people confuse it with evening rise of temperature. They say that it is evening fever. This is not evening fever. This starts at early afternoon and continues for 8 to 10 hours. Okay, okay. And again, after this fever again comes after 48 hours. Yes, we had seen this. That is why this is known as tertian fever. Fever comes in the 3rd day. Okay, but there is quartan fever, P. malaria. In that, fever comes in the 4th day. So that's not a great deal. Erythrocytic cycle in case of Plasmodium vivax completes in 48 hours. So fever, tertian. In case of Plasmodium malaria, 72 hours, fever is quartan. Okay, okay. So hemozoin was released in spleen. Don't forget this. This was the question in CE 2021. Okay, okay. Now what happens is, some merozoites are also released, right? So some merozoites, they will come again into the new fresh RBC and infect them. Okay, they will infect the new RBCs. But some of them, they will form gametocytes, and these gametocytes, they will be either macro or micro gametocytes. These will be taken up as a fresh blood meal by the mosquito, and that is responsible for the gamogony. In case of mosquito, we will be seeing gamogony in our upcoming lecture. Okay, not in this. So basically, erythrocytic cycle is the culprit for fever, and the fever is caused by hemozoin. That hemozoin is released in spleen. Hemozoin is formed during amoeboid stage. Okay, and the basic merozoite becomes trophozoite, signet ring, amoeboid, scisant, rosette, and again last merozoite stage, which then comes into the spleen and gets ruptured. Okay, this was about erythrocytic cycle. Now let's talk about some clinical aspects. Clinical aspect number 1 is fever. Yes, clinical aspect number 1 is fever. This fever comes after hemozoin release. Number 2, clinical aspect number 2 is recrudescence. What is this? This is similar to relapse. In this also, after 1 year or after 1.5 year, your fever is seen in relapse stage. But do not confuse it with relapse. This is different. This happens in, yes, Plasmodium falciparum and Plasmodium malariae. Okay, Plasmodium falciparum and Plasmodium malariae. Plasmodium falciparum and Plasmodium malariae, they lacked the hypnozoite stage. That is why they could not cause relapse. What they cause is recrudescence. What is this? What happens basically is, when you are suffering from malaria, you take the medicines. Okay. Now with the taking of medicine, your symptoms begin to subside because the number of the parasite load in your body decreases gradually. Okay. Now the parasite load is decreasing. Now what happens is, after a critical limit, you stop taking your medicines. Now. Now what the problem happens is, there are few, maybe 1, maybe 2, maybe up to 50 parasites, they are remaining in your blood, and now there is no symptom. What they will do is, they will continue their erythrocytic cycle and they will multiply in the number. They will multiply with 50, they will make 500, 5,000 and millions, lakhs. Okay, in that million, when they get again raised above the threshold limit to cause fever relapses, fever is seen, right? So recrudescence stage is seen due to incomplete dosing. As clinically, if you do not take the doses for particular required amount of time, it will go into recrudescence phase. Okay, and the fever will be seen again. So what is the basic difference between? Okay, so what is the basic difference between recrudescence and relapse? Relapse was seen due to liver schizogony, right? Relapse was seen due to hypnozoite, but recrudescence is seen due to erythrocytic schizogony. How can you prevent relapse? You can prevent relapse by giving such medications which act on passive non-dominant forms in the liver, right? You can prevent relapse by giving such medications which act on liver parasites, right? But you can prevent recrudescence by giving the complete regimen. If you complete the regimen, you will not find this recrudescence again. Okay, so recrudescence versus relapse, you got it. Relapse is due to hepatic erythrocytic. Give such medications which kill the hepatic parasite. Give complete regimen of the medication. Okay. Relapse found in Plasmodium malariae and Plasmodium ovale. Recrudescence in Plasmodium falciparum and Plasmodium malariae. Relapse is due to hypnozoite. Do not forget this. These are really very important. Okay. Now our life cycle will be continued in the next lecture, where mosquito will take up this macro and micro gametocyte. Okay. So at last but not the least, if you want to get quality notes of this chapter, you don't have to copy everything from my book, from me. You can see that in the book Conceptual CE. Okay. So let's keep it short and sweet. Only this much for now. Thank you and see you soon in the next video. Don't forget to see our next video, that will be on the sporogony and gamogony, right? That is the last video of this series, and that will complete our malaria playlist. Okay. So till then, keep studying and do not forget to check yourself from the pre-test evaluation of the MCQs. Okay. So see you soon in the